Sun. So I had just said that in the future that the Orion capsules will come out of the folding silver doors. But before it can go on top of the rocket, it's going to need one more piece of equipment. Imagine you're sitting in the Orion capsule on launch day and the rocket underneath you starts to blow up. You need to get away. So on top of the capsule, they'll install a small white tower called the Launch Abort System. You'll see an exact size replica later in the tour. It has 4 small motors that will light to yank off your capsule, take you way up in the air. Then the tower will fall off, parachutes will come out, and hopefully float down to a safe landing in the Atlantic Ocean. So to install an abort tower, they're going to bring the Orion capsule down the road we're on right now to the building coming up on the right. It has a small crane in the ceiling that will hold the abort tower. They'll bring the capsule through the sliding silver doors here up front, and then the crane.
SLS. The SLS is the most powerful rocket in history and has an evolvable design that ranges from 321 to 384 feet tall, depending on mission requirements. This rocket will someday help NASA to reach its goal of human exploration of Mars. The large tower next to the VAB is the mobile launcher being built for SLS. When completed, it will carry the massive launch vehicle on top of the crawler transporter to pad 39B. You will learn more about the launch of SLS when we get to the launch pad. Adjacent to the VAB is the Launch Control Center, the distinctively shaped 4-story building which houses the launch team. This is where the ground controllers, engineers, and launch director monitor the spacecraft and manage all the activities leading up to launch.
Thank you, David. Ahead of us is the Vehicle Assembly Building. When this was completed in 1966, it was the largest building by volume in the world. It's no longer the largest by volume, but it is still the largest single-story building in the world. If we were to walk inside and look straight up, 526 feet or 160 meters above us would be the roof. It's a 52-story tall, single-story building. Originally designed in the early 1960s for the Apollo Moon program, redesigned in the 1970s for the Space Shuttle, and now it's being remodeled again for Space Launch System and any private companies that want to use the complex, because for the first time in our history, we're a multi-user spaceport, both government and commercial. The VAB has 4 high bays. A high bay is just a giant garage for assembling a rocket, where you see the folding gray doors. 2 here on the west side and 2 on the east side. The 2 here on the west side on the left is number 4 and on the right is number 2, which means 3 and 1 are on the east side. 3 and 1 used almost always over the last half century, simply because that's the side that faces towards the launch pad. It was a shorter drive for the crawler. Now why 4? Well, when they designed all of this in the early 1960s, they had no idea how much capacity they were going to need. Some of the early designs suggested 6 high bays and 5 launch pads, but they were quickly told you're not going to get money for something like that. Get on with it. End of decade. So the final original design was 4 high bays and 3 launch pads, 39A, B, and C. Of course, we never built 39C, but if you know where to look, you can see vestiges of where they plan to expand. So, for example, on the north side of the VAB, they left foundations in place in case they wanted to add more high bays. The original roof on the VAB was a temporary roof because they thought one day they might be taking the building higher to build bigger and more powerful rockets to send people to Mars. Of course, that never happened either. Over the decades, the roof started to corrode, and then finally in 2004, we had 3 hurricanes come through in 6 weeks that damaged the roof, and that was when they installed the permanent roof. Also, when we're coming back from Pad B along the crawlerway, you're going to see a silver nitrogen pipeline. Where the road curves, it's buried underground and it comes out the other side. That was because that was where they were intending to extend the crawlerway up to Pad C, but of course that never happened either. As you go around the VAB, if you're thinking you're on the wrong side of the bus for pictures, do not worry, because when we come back for the launch pads, our third photo stop will be in front of the south side of the VAB. So we'll have 10 minutes there to get pictures. When we get to the traffic light, look to your right down the block to the next traffic light. To the left of that, you'll see a black fence, and that's where we're going to get out for pictures. Coming up ahead of us, you see the 3 tan buildings with the stripes around the top. That's where we used to keep the shuttle orbiters. Now that the shuttle program has ended, they're being used for new programs. Number 2 and number 1 are leased to the Boeing company for the X-37B. It's an uncrewed orbital space plane that Boeing flies on behalf of the Air Force. There are 2 of them. When they come back, they land on our runway so they can be towed over here to be refurbished and flown again. Across the street, you see the 3rd orbiter hangar. That is also leased to Boeing for their CST-100 commercial crew capsule. So when Boeing starts sending people to the space station around the end of the year, those capsules will come out of hangar number 3. The first 3 are in there right now in various stages of assembly. In just a moment, David will turn right to take us down Launcher Road. You see both of the crawlers that go back to the 1960s. The one that will be closer to us, closer to the bus, is on the left side here, has finished a 4-year upgrade for Space Launch System. It used to carry 12 million pounds or 5 million kilos. Now it carries 18 million pounds or 8 million kilos. Coming up ahead on the right, you'll see one of the 3 original mobile launch platforms that go back to the 1960s. Back then, it used to have a big red service tower on the left to support the Saturn V moon rocket. That was removed in the 1970s so they can install those 2 big gray upside-down U-tail service masts for the shuttle. The process begins with a crawler going over to get underneath the platform, picking it up off of pedestals, bringing it into a high bay. They assembled the new rocket above the flame ducts, then the crawler took it out to the launch pad. When it got to the launch pad has pedestals like you see here, so the crawler would lower the platform on the pedestals and then the crawler would leave, so at launch time all the planes go through the flame ducts into the trench below. The flames go through the flame ducts into the trench below, so you can see this is in the shuttle configuration. The opening on the front is for the 3 engines on the bottom of the shuttle orbiter, the 2 openings on the back for the white solid rocket boosters. So when it's a launch pad has pedestals like you see here. Crawler puts it on the pedestals and then the crawler leaves, so at launch time all the flames go through those openings into the flame trench below. Coming up on the right is a new mobile launch platform for Space Launch System. You can see the other tail service mast is sitting on the ground awaiting installation. For those of you on the right side, if you look out the window and try to crane all the way up to the right, you'll see a gray arm with a white room parked against the side. That will be the crew access arm for the Orion astronauts. So on launch day, that arm will fold out and the white room will be up against the capsule. The astronauts will go up the elevator in the tower, and they'll walk across that gray arm to get into the white room and then into the capsule. So sometime in late 2019 or early 2020, the upgraded crawler will come over, pick up this platform off the pedestals, take it into high bay number 3. They'll assemble a new rocket over that big flame duct there. Then the crawler will take it out to pad B. When it gets to pad B has pedestals like you see here. So the crawler will lower the platform on the pedestals and then the crawler will leave. So at launch time all the flames go through that flame duct into the trench below. Coming up on the right, you get a close look at the crawlerway. The crawlerway is the width of an 8-lane highway, 130 feet or 40 meters. It goes down 8 feet or more than 2 meters, various layers of fill, sediments, and rocks. You can see fresh tread marks when the upgraded crawler came out to do a fitting test underneath that platform last winter. Coming around over to the east side of the VAB, High Bay 1 on the left and High Bay number 3 on the right. Number 3 has finished an upgrade for a Space Launch System. We've watched them pull out the old technology. Some of that went back to Apollo. The white building coming up on the left is the Launch Control Center. It has 4 firing rooms. This is where the people are on launch day who launched the rockets. Now to clarify, this is only used in the past for our launch pads 39A and B. All the launch pads over at Cape Canaveral Air Force Station, they have their own launch control centers. So VAB, Launch Control Center in the past, all strictly for our launch pads 39A and B. Firing room number 1 on the far right has been remodeled for a Space Launch System. Number 4 on the left was used for the last 21 shuttle flights starting in 2006 at the end of the program, and now it's available to any private companies who want to use the complex. In just a moment, David will turn left to take us eastbound on Saturn Causeway out to our 2 launch pads 39A and B. Pad A is the more famous of the 2 pads. All 6 flights have put astronauts on the moon, as well as 82 of the 135 shuttle flights launched off Pad A. Since going operational at Pad A in January 2017, SpaceX has had 14 successful launches from Pad A, including on the 6th of February, the historic test flight of the New Falcon Heavy. I'm going to ask David to play to you video number 3 to tell you more about the history of Pad A. Thank you, David.
We are now approaching Launch Pad 39A. It was constructed for the Apollo program and is where all 12 moonwalkers began their historic journeys. You'll learn more about the Apollo program when you get to the Apollo Saturn V Center. Following the end of the Apollo program, Pad 39A was the site that launched Skylab, the first U.S. space station to orbit the Earth, on May 14, 1973. Skylab provided America's initial experience with long-duration spaceflight. During 1973 and 1974, 3 Skylab crews were launched on missions of 28, 59, and 84 days. The first space shuttle mission was launched from here on April 12, 1981. Over a period of 30 years, there were a total of 135 shuttle missions. 82 lifted off from this launch pad. The reusable space shuttle system transformed the way we operate in space. The space shuttle launched dozens of communication satellites, as well as robotic spacecraft on groundbreaking missions to Venus, Jupiter, and Saturn. Not only did the shuttle deploy the Hubble Space Telescope in 1990, but it conducted 5 repair and upgrade missions that enabled the Hubble to literally rewrite astronomy textbooks. The Space Shuttle program ultimately assured its place in history with the complex